Let me introduce you to a discussion of target non-target screening. And this flowchart shows the quantitation part over here and what I'll concentrate talking about, which is the unknowns analysis, non-target screening, which uses a form of deconvolution with a library to look for hits. And if you're coming through the target way, you'll get the targets matched to find tentatively identified compounds. All right, here we are looking at a flowchart. This shows you what happens with unit mass. So we'll get integrations, we'll deconvolve them into components, and those components will be looked at with library search, finding library hits, and we also use a new technique of multi-parameter and best hit to come up with a list of best hits, and then the tentatively identified compounds. So this will appear in a presentation of unknowns analysis. With unit mass, this compares the one pass through deconvolution versus multi-parameter and best hit technology. And you can see the number of matched targets, especially at the low end of the concentration, increases significantly. That's almost 2x, less so on the high end. And if we look at the evidence of the average library match score, every case shows that the library match score is increased in the right direction. And unknowns analysis uses the unknowns method. Deconvolution parameters, the libraries, library search, retention time constraints, compound identification filtering, and if you're coming from the target end, target match. The procedure in accurate mass with a TOF is different than unit mass. First, it starts with an exact mass library. And the reason that's important is it makes a list of mass values and eliminates redundant exact fragmentation masses. Now, next comes deconvolution, which also uses the multi-parameter and best hit game to get a better match score. And last, it uses this list from the exact mass library to tell you whether those non-targets are appearing in your chromatogram. Reverse library match has several advantages. First of all, it's faster. So if we compare that to accurate mass deconvolution, you'll see that the times for all of the mass extraction windows are reduced significantly. And as a rule of thumb, it's about a minute a sample. Reverse library screening is fast. This graph clearly shows that the target find rate for accurate mass is much higher if you compare that with a flat deconvolution approach versus a reverse library match, which knows the ions from the library. You can see how effective it is across a number of matched targets as well as the metric of average library match score. So for the demo, I'm here in Quant, and let's look at some T sample. And you can see here a particularly large response, and if we look at that peak up close, you can see it looks real. And if I zoom in on the deconvoluted scan, you can see there's quite a bit of correspondence between these ions looking at their exact mass. So I'm going to go very light here because this has been demonstrated, and I'll move over now to unknowns analysis screening. All right, let's create a new batch here. And I will give it the name of non-target analysis. Non-target analysis. And I will bring in the batches from the quantitation. Now you can also just add samples and use unknowns as a standalone. And next I'll just go get the method and load it to all the samples. So I've got a method here that I've called unknown screening 2, and I will load that, and let's take a quick look, and then we'll start up the analysis. So if I edit that method, I can see I've got a 50 ppm window. There's my library, compound identification. target match switched on, and you can see I am using multiple parameters. One thing to be sure to check when you're doing reverse library screening is in deconvolution, go to advanced and go all the way to the end here and make sure that the screening box is checked for all of the samples. So let's start up the analysis. Here I go, and they're all cranking with the multi-core. We finished the processing, and let's take a look at the non-targets in this gunpowder sample. And first we've got trizophos, and you'll notice a very high component shape quality here. The component shapes look pretty good, and if we look at the ions, they do match up. One more, also you see good component shape quality, and the ions line up. What we normally do is spend time looking at the targets because we know they're there. So you'll see, as you saw before, that chlorophenol here is there showing some strong ions, and if we zoom in on those ions, you'll see a correspondence between the exact mass pattern that was created and the actuals. And one more, biphenethrin, you also see a component shape that fits, and if you zoom in on the ions, you'll see the pattern matches. Thanks for your attention.